Thank you all for giving me the opportunity to come and chat about our Tri-City Outfall project. For those of you that aren't familiar, we're down by the bridge. Our outfall is going in down there as we speak. It's a 90-inch diameter pipe, and this presentation really is more about a story kind of about the project. I've been working on it for 7 years, and so it's taken up a large chunk of my life and my thoughts over the last 7 years. So a very exciting project that I was lucky to lead. But before I dive into kind of the meat of the presentation, I'll take 2 slides here and kind of introduce Water Environment Services as an organization for those of you that might not be familiar with us. We don't invoice everybody that's in our service area, as we do provide treatment services only, so you might not ever see us on a bill. So just thought I'd take a few moments and talk about WES. And so about 3 years ago, we embarked on a kind of a mission and vision rebranding, if you want to call it that. And so I'm not going to read them out loud, but I think that the vision is really a reminder to me on why I'm in the industry I'm in. I love being out in nature. I love being out on the water, and it's why I'm proud to work for a wastewater utility, which is not the most exciting conversation starter at parties when you tell people what you do. It's not a lot of follow-up questions, but it's something I'm really proud of, and it holds near and dear to my heart and my life holistically. My wife also works for a wastewater utility, so for us, she works in Washington County, I work here. We keep the waterways clean in Northwest here. So WES is the surface water and sanitary sewer server for Clackamas County. We provide services to about 200,000 customers in our region. We have 5 treatment plants, so we call them resource recovery facilities now, not wastewater plants. So we actually do recover some of the resources for biosolids and things we take out east and apply on fields for seed growth. So we're more than just a wastewater treatment plant. We're a resource recovery facility. We capture biogas in our digesters, and we burn that at our treatment plant to make power and heat for our facilities. And so we really try to capture everything and be efficient with what we do. As I mentioned before, we provide treatment services. We provide collection for unincorporated Clackamas County and treatment services for Westland, Gladstone, Oregon City, and Milwaukee. We have 2 flagship plants. The Kellogg Treatment Facility is located in Milwaukee, and that is identified up there in the Milwaukee, right on the Willamette River, and we also operate a facility in Oregon City. That's our Tri-City Resource Recovery Facility. And so the real driver for this project is Kellogg. It has no room for growth, no expansion. If you've seen it, it's right next to a park and right in a beautiful downtown Milwaukee, and so we can't expand that facility. So all the growth we're going to see in our area and our service area is going to come to the Tri-City plant. So this outfall is really to provide the necessary capacity for the future growth of our region here. And that is why this project is so critical and the size is so large, because it's really for a project that's going to build us out through 2080. So we have a 60-year kind of planning horizon on this project. So before I really dive in, and I'll just say I'm going to tell a story about our project. As I mentioned, I've been working on it for 7 years, and so it's not a lot of graphs and figures and numbers. It's more really project delivery story and how we've utilized collaboration with our member communities, permitting agencies, tribes, other folks to deliver this project. It is a very unique project, and it's one, for me, it's kind of a once-in-a-lifetime or once-in-a-career project to lead a project like this. I'm very fortunate to have that opportunity. So we made a video to help kind of have that conversation and show people some graphics on how this got built. It's a tunnel which has its own unique things, and so I'll be quiet for a few minutes and you guys can watch the video. I think it'll be pretty informative.
The Tri-City Resource Recovery Facility Outfall project is a vital step forward in protecting water quality in the region. Clackamas Water Environment Services, or WES, launched this project to expand outfall capacity and ensure compliance with Oregon water quality standards and federal requirements, while benefiting the river, the community, and the environment. The new system will provide greater dilution and reduced discharge concentrations by relocating the primary outfall to a deeper section of the river. It's also equipped with a multi-port diffuser to provide rapid dilutions that help protect water quality year-round. By moving the discharge point farther from the Clackamas River, the project helps preserve seasonal cold water refuges crucial for fish and aquatic life. Other benefits include enhancing the protection of beneficial uses in the Willamette River, maintaining nearshore and offshore fish passage, minimizing construction impacts by using trenchless methods beneath the riverbed, and installing an integrated outfall system that includes a new 90-inch diffuser with 18 risers, while retaining the existing 72-inch outfall for peak wet weather events. Altogether, it's a comprehensive solution for long-term environmental health. Designing the alignment for the outfall was a complex challenge. The project had to work within the footprint of the old Rossman landfill and avoid existing critical utilities along Agnes Avenue, and deal with poor ground conditions, all while minimizing disruption to public infrastructure and private property. It crossed several key areas like Agnes Avenue, Main Street, Interstate 205 and its ramps, Highway 99, Clackamas Drive, and John Storm Park, which required a special easement. Wes worked closely with stakeholders, including local residents, property owners, the City of Oregon City, and ODOT to limit construction impacts. The alignment used a combination of methods. About half was open cut along Agnes Road. The other half-mile section was constructed using microtunneling, launched from a 28-foot deep shaft and ending in the Willamette River. Challenging soil conditions required a specially designed microtunnel boring machine imported from Germany. And as is common on tunneling industry projects, Wes promoted a contest for naming the tunnel boring machine, with the community selecting the name Clackamas. Construction kicked off in July 2024 with the excavation of the 28-foot launch shaft. By the end of August, Clackamas was launched, slowly advancing underground by cutting through the soil and pushing pipe segments forward with hydraulic jacks and lubrication systems. To avoid disrupting John Storm Park and the riverbank, the tunnel includes both vertical and horizontal curves. Tunneling was completed by December 2024. In January 2025, the tunnel was cleaned out and flooded. Then, using a crane on a barge, the boring machine was lifted from the bottom of the river, disassembled, and shipped back to Germany. Meanwhile, open-cut installation along Agnes Avenue began in May 2024. Over the course of a year, crews connected the new pipe to the Tri-City treatment facility and prepared it for integration with the tunnel. The final step was installing the diffuser in the Willamette River. Scheduled for completion between July and October 2025, the diffuser will feature 18 risers. Though the main outfall pipe is buried below the riverbed, the risers, equipped with tide flex valves and breakaway joints to protect the main diffuser pipe, will extend slightly above it, enabling rapid mixing of treated water with river flows. Once complete, the new outfall and diffuser will serve as the primary discharge point for the Tri-City treatment facility, ensuring clean water in the Willamette River for generations to come.
So the project was identified. We do planning documents, so that's the basis of all of our capital plans, right? That's a plan in itself, but the capital plan is comprised of studies of our system. So we have a surface water master plan, a sanitary sewer master plan, facility plans for our treatment plants. And so that's kind of how we identify what projects we need, when we're going to need them, to make sure we're delivering projects that meet the needs of our customers, not too far in advance of when we need them, but also not too far behind when we need them. So there's this kind of just-in-time delivery is what we think of, or just, getting it built when we need it, not before or not after. And so this project was identified originally in our sanitary system master plan. We currently have an outfall that was mentioned. It's a 72-inch outfall that goes to the Willamette River that's been in service since the mid-'80s. It is reaching capacity, and so we needed to go bigger. So the master plan, looking at our build-out, allowed us to size the capacity of our new outfall. And so our new outfall and our old outfall combined needed to have, and according to that planning document, 167 million gallons a day of capacity. And so the combination of the two is what will operate moving forward once this is brought online. So knowing how long that was going to take, we started this project back in 2018 to hire a consultant to come on and help us identify how do we get from our plant, and we need to get to the river, the Willamette River. Where are we going to go in the river? And so we started that a project to bring in someone on board. And so I'll just make the note here. The Clackamas River is right next to us. Why aren't we going to the Clackamas River? I think it's a critical thing. The DEQ, we have a rule in Oregon called the 3-basin rule, and so there's 3 basins, And the Clackamas is the one that's most near and dear to my heart because it's the one that impacts my work, but they won't permit any new discharges to the river. That's the main source of drinking water and an environmentally sensitive waterway. And so, while it would have been, from a practical sense, easier and more straightforward and a lot cheaper to go to the Clackamas River, we went to the Willamette River due to permitting and regulations. So we started, as I mentioned, we brought a consultant on board and we started with a routing study. And the first part of that routing study is really to figure out what is the endpoint, where do we want to be? The river's a broad range of locations. And so what we really targeted, or what you really look for an outfall pipeline, is you want it deep to allow really good mixing, and you want a really stable river bottom. And I'll say we're fortunate here in the Clackamas River, it's really a stable river bottom. It's mostly cobbles and gravels. It doesn't change much over time. Historically speaking, the river bottom stays really stable, which is really good for a discharge pipe of our nature. For an instance, out in the Columbia River, BES has to contend with constantly digging their diffuser pipes out or have their risers really tall because the sand and silt is moving around that river, constantly changing the bottom of the river. We don't have that issue here, which is really good for us. And so when we did a bathymetric survey looking at the river bottom, the target that was identified was right across from John Storm Park. And so the phase 1 part of it was identifying that. And then we spent a bunch of time looking for how do we get from our treatment plant out to that spot in the river. And so this kind of figure up here depicts all the different options that we were looking at. And so a couple of things to note. During that time, ODOT hadn't decided whether they were moving forward with their bridge project, so we were looking at how we could collaborate with that project. The cove development was looking like it was going to go, so we were also trying to coordinate with that group to figure out, was there a route that we could use that property before they built on it? How could we get here? What's the most effective cost of, not only cost, but environmental concerns and other things? And so that phase 1 study really landed on in a route to the river that paralleled 205 was what we ended up picking on that. And so with that, we were going to go underneath John Storm Park, and many of you are from Oregon City, and there's a city code that requires any non-recreational use of a park property needs a ballot measure. So it's a vote of the public, right? And so in January of 2020, we kicked off this ballot measure initiative working with Oregon City to get on the November 2020 ballot measure. And so as we ramped up, we did a whole communications plan, and then in March, the whole world changed. And we had to re-envision what that was going to look like. How are we going to get the support of a voting public that had much larger things, quite frankly, to care about? Keeping your family safe, keeping food on the table, how are you managing healthcare and childcare and all of those things. And so we really had to re-envision what that looked like from an outreach perspective. And I'll say our relationship with Oregon City and staff there really helped us get it on the ballot measure for November while all this craziness was going on. And from a virtual outreach perspective, we really had to go out. I won't say go out because we weren't able to go out, but we really had to pick up the phone and call, and we talked to anybody that would listen to us about our project, whether it was groups, community groups, individual businesses. I think I gave a presentation on the Outfall over a 5-month span 30 to 35 times to just anybody that would hear about our project, just trying to make sure that people are aware of the need, why we wanted to do it. It wasn't going to impact your taxes, those types of things. And so it was really something that I'm pretty proud of, the way we were able to shift gears and really focus on that. And we actually ended up winning an award from the Association of Counties. We had a public outreach award for our work. And in the end, we were successful in our ballot measure. We got a 72% approval of it, which exceeded our expectations or our hopes, obviously, but it allowed us then to continue moving forward with the project. So as we were running through this outreach, we were kind of pausing to make sure we could get approval for this route before we moved our design forward. 73%, I apologize. So once we had our route, and we had the voters of Oregon City approving of us building our pipeline underneath the park, it was now the technical side of how do we get from point A to point B. And if you've walked the corridor along 205, there's on-ramps, off-ramps, 99, John Storm Park. It was very clear early that half of this project was going to have to be a microtunnel, or not a microtunnel, a tunneled operation, unclear on what style of tunneling we'd be doing. And so because of the high level of risks involved in that style of construction, we elected to look at bringing a contractor on board. An engineer can design it, and we can do drillings and other things, but we don't really know what contractors are comfortable doing. And so we elected to go progressive design build. So we took that to the county commissioners, or our governing body, to ask them, can we do an alternative delivery? Here's how we want to manage our risks, and that's the reason we're doing it. And so we got approval to move forward that way, and we went out and procured a contractor. And so progressive design build is a different way of delivering it. So a traditional project, public works project, is you would do all of your design, you'd put a document out to bid, a contractor or contractors would price it, they would submit it, and it's called design bid build. Progressive design build is you're picking a contractor based on qualifications. So similar to the way we would pick an engineering company, we put a document out and ask for, why are you guys qualified to do this? Why should we pick you to work with us on this project? And so we really had to do some outreach to contractors and get qualified contractors, quite frankly, to come work for us. And so we were lucky on our change of delivery to work through that. And so in order to do that, and it takes time, we've never delivered a progressive design build, so we had to navigate the new contracting, different contracts to use those. And so I learned a lot about contracts. And so we had the support of county council. We had an owner's advisor that had done a lot of progressive design build help us generate these documents, right? It's a lot of different things are in these documents than what would be a traditional design bid build. And so I learned about indemnifications and how we're going to manage change on something that's a guaranteed maximum price and those types of things. So it's a really different shift in mindset too. Was a good crash course for me, and I was happy to have really good support at the county and also from our design team or our owner's team to help navigate those. And in the end, you're working through, as I'm going through the process, I'm like, this is never going to come into play. And I realize it's not that it's never going to, but it's that I hope it never comes into play, and I hope that we have good language in there to protect us and the county should we need to leverage those things. And so I'm not a lawyer, I'm an engineer. But I learned a lot in that 6 months while we put these documents together. And I feel really proud of what we have out there. And I think I'll have slides later to talk about some of the change and some of the hurdles. I think we had a really good solid set of documents that have helped us engage with our contractor in a really collaborative environment in a good way. So the big thing about progressive design build, as I mentioned, is it's this shift in team dynamic, whereas a lot of times when you're building things, it's somewhat of an adversarial push and pull relationship where you're immediately at odds with the contractor. And this platform, the contractor's part of the team, and so it really is a project thought process, which takes some shift in mindsets of everybody that's part of the team, I'll say, and it doesn't, depending on the personalities that are involved, it doesn't always go well. I've heard a lot of horror stories. I've heard a lot of success stories. I would deem ours a success story. But we were able to get Michael's Trenchless as a tunneling contractor. They're a nationally recognized firm. They do really good work. They're really innovative. They are really good at what they do, with AECOM as the design firm. And so we had this team. We had myself for Wes. Jacobs is our owner's advisor. Michael's as the contractor, and AECOM as the design engineer. And so all of us working together towards one goal. And I think that was really eye-opening to me to see how much conversation around risk. I got to, I'll say, as a owner, I got to peek behind the contractor's curtain a little bit to how that they look at projects and how they look at risk and how they price things. And it was somewhat eye-opening to understand that shift of who owns the risk, how are we going to manage this risk. And so there's an extensive amount ad nauseum in some regards about risk and cost and who owns that risk and where does that apply. And so it was over the following year was really whereas I was into contracts before, now I'm into risk on the project. And so a lot of technical pieces, but a lot about risk and who's managing that and how we're navigating it. And so the lesson I learned is somebody can put a price tag to it. You can design the risk out of the project, but in some way you have to have some documentation on how you're managing that. And so this slide is, you assess the risk, then you see if you can mitigate it, and then you monitor it as you go along. And so when I talk about risks, this is just a graphic we used, and so you can see all of those buttons are different things that were identified, and we built what's called a risk register. So it's a big spreadsheet with all these columns and rows and all the different things that could go wrong. For everything from we lose somebody critical to the project to our machine gets stuck, or we unearth something that we shouldn't have from an archaeological perspective, right? And so you really try to throw everything at the wall and then figure out some balance of happy medium on how you can manage it. So it was again, not having a significant tunneling background personally, I learned a lot about kind of how to navigate those, but also about tunneling, but also just about communication and risks, and like I said, the way the contractors view things, which is really helpful for me, I think, moving on as we continue to deliver large capital projects, understanding their perspective a little bit more. You get that collaborative perspective conversation as opposed to adversarial. I got a lot out of that personally. And so since we knew this was going to need a nationwide permit, so a nationwide permit is basically the Army Corps of Engineers administers it, and they reach out to all of the agencies that might be impacted. That could be DEQ, State Historic Preservation Office, ODOT, anybody that we're going to impact on this project. We're issued one. The nationwide permitting process is to avoid you having to go and get a ton of individual permits, so you get one big one. But it opens up a whole level of scrutiny, I'll say, and conversations. And so knowing that anytime you're building next to a river, in Oregon particularly, right next to the confluence of the Clackamas and Willamette River, it is ripe with potential archaeological concerns. And so when our ballot measure got approved pretty quickly thereafter, we knew we wanted to get out and talk to the tribes and really try to build relationships to understand what their concerns might be about our project, but also kind of that our project was coming their way, that it was something they're going to have to weigh in on. And so in late 2019, we did a site walk, late 2020, we did a masked up site walk with the tribes. And Grand Ronde tribe was the tribe that joined us on our walk, but we were able to tell them about our project, how we were approaching it, how tunneling works, how deep we were going to be, what that all looked like. And so that was really the first step in building a relationship with a group that really could have a big impact on what we needed or how we could build our project. And so we really tried on this project to take the more is better, early and often communication and collaboration will really help us in the long run. And there's a few slides later that this relationship building comes back into play and really helps us in our delivery. So we took that very seriously, and as you can see, this slide was something that we used with Oregon City at the council meetings to talk through kind of the level of what we were doing. There were some interested parties there that we wanted to convey. So we put this slide together to talk through the nationwide permitting and how many times we have touch points with different groups. Oh, by the way, there's another project, 200 feet from where we're trying to build our project that's just a tiny little guy. And so we started collaborating with ODOT really early as well. As I mentioned, we even looked at could they build as part of their project our in-water pieces, right? They're already there. From a permitting perspective, that wasn't possible, of course, but we tried to leave no stone unturned for how we could get this in the water, not have so many in-water periods be impacted. It's it's called the trash hole. People love fishing there, right where we're at, this huge stretch of river that's recreationally from a fishing standpoint used all the time. And so we had to figure out how to work with ODOT for us to all occupy the river at the same time, which I'll say was not always that much fun. They obviously have a much bigger project than we are, but they don't own the river, so there was a lot of push and pull and timing and sequencing and looking at it. And so part of the reason we ended up with our tunnel reaching the river last December and us building the diffuser this year was because the space needs down there it was too much for all of us to be down there last year. And so it worked out fine from a sequencing standpoint, but it was definitely something that I'll say, having the contractor on board to be a part of those conversations, to understand before he gave us a price what they were getting themselves into with the other project and everything was really beneficial to us and really helped us control our costs from that standpoint. And the ODOT project managers and project team were really good to work with, quite frankly. They understand, right? We all want to build public projects that benefit the public, and we don't want to draw out impacts to the river any longer than we have to. So while ODOT as an agency can sometimes be really hard, the mothership of ODOT can be hard to work with and get permits through and stuff like that. The project team, which is where the relationships come into play, right? They were really good to work with. And so I feel like we were successful at navigating that and getting to the point where we were in the river together, playing nice in the sandbox. So you have all this coordination and collaboration up front. You get a price from the contractor to build the project, and then you shift away from this design phase to this construction phase, and it's always good to celebrate, right? I think it's always good to kind of, as an sometimes as people in general, but as an engineering group or organization holistically, our nature is to focus in on what went wrong, lessons learned, how do we do, and so I guess I'll just say a lesson I learned from this project, and I'll reiterate it a few more times, is like celebrate the successes, enjoy it along the way. It's a reminder sometimes when you're in the details to take a step back and see that, wow, this is an amazing project I'm part of leading is pretty awesome. And so it was good to have people, our communications people and other things really kind of lead the charge with those things so I could focus on what I'm good at, they could focus on what they're good at, and I could be reminded to have fun. And so we had our ribbon cutting, our groundbreaking ceremony, and we had members of the community, members of the press. It was just a really good celebration. And for me personally, I'd never wielded a golden shovel, so it was fun to have that. Just in case you were curious, if you've never used one, it's not any easier to dig with a golden shovel than my normal shovel I have in the backyard, but it's more exciting. So it was really fun to celebrate those successes. And so we're ready to go, and so I'll say one more thing, again, about celebrating the successes and having fun. Our communications folks said, hey, most people name a tunnel boring machine, we should do a naming. And I was like, oh, one more thing to add to my, but I'm gonna just be honest, that was my initial reaction. I was like, something I don't know. But okay, if you guys want to run it, great. I'll support that. That's not a problem. And so we did this amazing, very short-winded naming adventure, I'll call it. Opened it to the public. We got over 600 submissions in about a month. We had about a month, 600 submissions. I think 500 were safe for work, 100 were not safe for work would be what I would take. There was some really interesting ones. But we landed on the Clackamas, which I'm sure you guys have heard before. But for me personally, it was like this really cool way now to talk about the project. Instead of talking about this Outfall, it's, hey, how's the Clackamas doing? Or, hey, here's an update on the Clackamas. It completely reshaped, quite frankly, the communication and the ability to communicate about the project. And so another lesson learned for me was, again, have fun, right? Open yourself up and have some fun delivering a project, because it was really cool, and now it's known as the Clackamas. And yeah, I think that ended up being a really cool name for us to have that communication. So I mentioned before this relationships with the Grand Ronde tribe, and so when we initially permitted our project, we anticipated that we would come out of the slope of the Willamette River adjacent to John Storm Park. So we weren't sure that the contractor would be able to do a horizontal curve and a vertical curve, and I didn't talk about the geology because it's dirt and rocks, and it's really important for this project, but overall I'll give a little primer. There's 3 layers of geology that we were looking at drilling through. Sandy and silty top layer, okay for drilling, really wants to close in on you pretty quickly, and so not the best material to drill through. And then the next layer down was more cobbles, but smaller, still a little bit of sand and silt, a much better layer to drill through. And then below that, you got into much bigger cobbles and really hard ground to drill through, also not good to drill through. So you had this kind of 2 levels that weren't great to drill through, one that was suitable. And so when we originally permitted it, we anticipated staying in that middle layer the whole way, especially because we were going to have to do a horizontal curve. We didn't think that the contractor would want to then do a vertical curve down into this really hard to drill through material. they felt confident with the right machine that they could drill through it, so we stayed shallow all the way up through to the cloverleaf, essentially, there in 99 interchange. So we stayed, and by shallow, at that point we were 45 feet below ground because of all the fill for the interchange, right? But shallow in that layer. And then we dove and went down another 30 feet down, got solidly into that and went out to the river. And so we permitted coming out the side of the river, and we went back to the permitting agency and said, here's our new plans. We're going to be way less impactful. This is great for everybody. That's what you would think. And so what ended up happening is we got a lot more comments the second time, and we didn't quite understand what happened. And so what we found out was when we initially submitted our application, the Grand Ronde tribe was short-staffed, and so nobody really looked at the project. And so here we were thinking, this will be smooth sailing. We didn't get any comments the first time. This is way less impactful. We're not going to get any comments, but we ended up with comments, and that early walk then came into play as we were able to navigate these comments and concerns with the tribe, which was great because it allowed us a pathway forward. They understood kind of what we were trying to do, what the limitations we have, and so, once you get a drill machine moving in one direction, you don't want to stop it. If you stop it for any real length of time, right, the ground's always trying to close in on you. And you can think the further out you get away from your launch, the more force you have to overcome. And so you don't want it to get stuck. If it gets stuck, then the ground wants to squeeze in. And so they understood we couldn't stop and pull samples ahead and other things like that. And so we came up with this really cool approach that, again, this collaborative approach with the tribes. So we brought in canine cadaver dogs. And so as the machine was going forward, we would take samples of the material coming back. We would put it in buckets and identify kind of the stationing along the alignment. And then when we were done, we were able to take the buckets that we had collected. It was like 85 buckets of material, spread them around the facility there, and then walk dogs, these canine cadaver dogs, around to look for any potential scent of human remains or any kind of archaeological type related things. And so it was just, again, it was frustrating in the moment that I felt like it was going to sail right through. We had to shift gears. We were able to come to an agreement and not hold our project up, and come up with this really neat way that I think other projects in the future could use to help navigate this kind of approach of making sure you're protecting these really culturally sensitive areas. So just a few of the things on there that I'll talk about is those log pins. And so these are things that came through our machine and came back to the front, not necessarily super historical, but those log pins in the Willamette, they used to get logs, and they'd knock these pins in them, and they'd tie these big rafts and send rafts of logs down. And so those were some of the things that we found. And interestingly enough, we were below the river bottom, so we were from the Johnstone Park. We were about 50 feet down, going underneath the park, and so to find some of these things that far down was fascinating to me. But they came through our machine. And so now we've got approvals, we've got all our re-permitting done, and we get to, again, this whole celebration, right? Celebrate the milestones. Our tunnel machine arrived, and we were able to host an event to have the public out to the site if they wanted to come and see our tunnel borer machine. And this is, it's a 50-foot long machine. It's 10 foot in diameter. This is a really massive piece of equipment, and kind of to get right up close and personal with it before it left was a really neat opportunity. We had members of our communities and commissioners and other things visit, the news. And so it was, again, just a really nice touch point to celebrate as we were going to embark on our massive journey to the river. And so just a real quick on tunneling, how it works, right? So you have, for our project, the pipes themselves it's a 90-inch diameter pipe, but the outside, by the time you get all the concrete so it can withstand the forces going through, it ends up being about a 9-foot diameter pipe. So they drill it call it a 10-foot tunnel. And so we're drilling a 10-foot tunnel, and so every 10 feet, because of the size and weight of the pipes, a 10-foot section of that pipe weighed 35,000 pounds. And so every 10 feet of pipe, they'd have to stop the machine, pull the jack back, lower a new 10-foot section, disconnect all the utilities, reconnect all the utilities, and then push it forward another 10 feet. And so it's a really slow process to build, I'll say. It's labor intensive of connecting and disconnecting these pipes. But it was super interesting to see, we got to take our advisory committee down and see it and other things like that. Just a really interesting process to build. So with tunneling comes risk, and you try to manage the risk, and you have buckets of money, and everybody's happy and excited. And then in October, as we're just getting out from underneath Highway 99, I got a call that the tunnel machine got stuck. And it's like the most heartbreaking thing you want to hear on a tunnel of this size. At that point, we're 70 feet below ground, just outside of Highway 99, and they're like, yeah, we can't move it. In the front, there's a cutting wheel that spins and it crushes, and it pulls the solids back, and so that's got stuck. And so I'll say, if we were going to get stuck, that was a pretty reasonable spot to get stuck. I'll say we weren't in the traveling lanes of 99. We were not inside the park yet. It was outside the park territory, still within the right-of-way of ODOT, so we weren't impacting the park, I'll say. I mean, it's right there, but from a property boundary standpoint, we weren't in the park yet, which was good. And they brought a drill machine in, and they drilled down vertically. And so 70 feet down, they put 14 vertical holes down, trying to loosen up in front of the machine. And so the thing this is when I knew we picked the right contractor, right? You hear, like, they were doing everything they could. And so I think it was somewhat to identify what was in front of them, but the spacing on the holes and things, right, were such to break loose, but also to verify how big of something might be in front of the machine. This machine could pass a 36-inch, could crush up a 36-inch boulder. It was basically the scale of what we were designing for. So they punched a bunch of holes, didn't hit anything significant. Were able to loosen it up, and they got the drill head spinning, but then the pipe was stuck because that took about a week. And so a week later, the ground had closed in our pipe, and we got the head spinning, but we can't push anymore. And so it was a lot of back and forth. And so one of the decisions we made in our risk conversation were these joints. And so when you're pushing on curves, you can think you're point loading different parts of the pipe. And so they use these special joints. It's like a packer. You can use wood. We went with a more, I'll call it a more intelligent, but it's not really intelligent, but we went with a hydraulic hose that measures pressure. It's called a jack troll joint. They were not cheap, but it was something that was like, we've got all these curves. We want to make sure we can figure out what's going on, make sure we understand. So when we got stuck, using that technology, we were able to figure out, we had about 2,000 feet of pipe in the ground. We were able to figure out the 100 feet that was experiencing the issue of not being able to move. So we would get responsiveness here, and then it would all stop in this 100-foot. And so I think the reason we were able to get this thing going is because of that joint, and we were able to focus our efforts on water jetting and areas around that to try to loosen up the soil in that region of the pipe. So we were able to focus our efforts on that 100-foot of pipe instead of the 2,000 feet of pipe. And the faster you get going, the better off you are, because if this is stuck, every other place is not likely far behind. So we were able to get it going, thank God, because we were at our last kind of stretch of what we could try. But we were able to get it free, and we were able to make it to the river. So I'll go back to collaboration in the city of Oregon City. It's about a week after we got the machine going, it's like, oh, thank God. We got a call from park maintenance saying, hey, we think there might be something going on here. A couple of bricks have fallen in the ground here in John Storm Park, and we go out, and thank God they didn't walk on it, and we're very fortunate because what we found was there was about a 13-foot deep sinkhole if you know where John Storm Park, if you know the bathroom facility there, the pavers, the maintenance person, I saw, hey, a couple pavers are not where they should be. There's a hole here. We were able to get out there within a couple of days and have the hole filled just to keep drilling, and we were able to then come back and rebuild that paver area and put it back the way it was. And I think that goes with the kind of, as I've continued to say collaboration, I apologize, but like the relationships we've built with Oregon City Public Works and Parks over time, right? It's a really good relationship. We were able to say, hey, we'll rebuild the pavers, we'll put it back the way it was, and there, what could have been really contentious, and thank God nobody got hurt, and I think we're really fortunate there because that was really just lucky in my opinion. It turned into a really nice collaborative, like, give and take on that, and so it was, again, communication and collaboration with folks is really critical to project delivery. Okay, then we made it to the river. Yay. It was super exciting. We punched through on November 31st, and they were able to get it all the way out. We had built a pad in the river, so the machine sits out there. And so in my head, it was like, okay, we're gonna move the machine and lift it out. And it wasn't until February that we lifted the machine out. But in the meantime, they had to remove all that 2,000 feet of utilities and fix the pipes inside anything that they used to hang and things of that nature. And so we got to do a pipe inspection, which was, again, kind of a once in a lifetime. I walked from Main Street roundabout all the way to the middle of the river, in this 90-inch diameter pipe, which was really kind of a unique experience. And I signed the pipe. So if anybody ever gets on the inside of that pipe at some point in the future, my signature's in there. So part of this wet recovery was lifting that thing out of the river. And so basically they did all their work, they got their utilities, and then they were able to flood the pipe and then make this lift. And so as I mentioned, this thing's 50 feet long and it weighs about 270,000 pounds. And so they were able to, again, the ODOT project and the collaboration we were able to leverage with ODOT, we were able to have their barge make the lift. They had one of the only cranes big enough to make that single pick. It was the single biggest pick that Michael's had ever done from a wet recovery. And so we were able to, on a brilliantly sunny February day, get the machine out of the river, which was just a huge milestone. And making it to the river was awesome, but to see it come out of the water and emerge and everything was really, really cool. And so I've talked so much about one half of the mile. The other half, if you caught on the video, ran through the Rossman landfill, and so not an easy pipe to build either. Right adjacent to two 72-inch pipes. One is an interceptor bringing sewage to our facility, and the other 72 inches taking water back to the river in our existing outfall. And so we had to contend with this corridor of, now we have a 90 and two 72s. That's a lot of pipe underneath the ground. But we had to dig through the landfill and permit that and jump those hurdles as well. And so it was a pretty interesting, we didn't uncover anything surprising. I mean, it was just, you didn't know it was an unpermitted landfill, so we didn't really know what to expect. We could drill here, but 5 feet away could be something, a car or a train car, something like that, real random. And so we made it through there without any issue, which was really good. But also not an easy part to build, because how do you support your pipe, right? If you've driven down Old Agnes Avenue ever, it is a humpy, bumpy road. And so we ended up over-excavating out refuse and rebuilding underneath there back to solid ground so our pipe would be stable. That's the last thing you want for a pipe, is to have some weird uneven settlement on it. And so that was the approach we took. And again, that was a conversation with the contractor, because we could have driven piles to support it. We could have done a number of different ways, but the cheapest way was to overdig. Then I'll go back to adjacent property owners, right? In addition to Oregon City, we worked with them to get access to the Cove area for hauling routes and different things like that. Again, leveraging those relationships. But then, not very far from where we did our launch shaft was an apartment complex. And this is a 24/7 operation. Once you start that machine, it runs 24/7. So we got one noise complaint 3 weeks into the project, and they sent me a video, and I said, oh, dear God, you got to get a different excavator. This thing sounded like it was from the 50s. It was so, I felt bad when I realized just how loud it was. But within that day, they swapped out excavators into one that was really quiet. Just the track on it was greased appropriately, is my guess. But anyway, it was that was it for what we did and the time we did it, to get one complaint to people that were just 100 feet away from you or 100 yards away from you. It was pretty nice. And then right now we're in the middle of building our diffusers. If you've been down by the river, there was a barge with all these big pipes and diffusers down there. They're going in, they're working on setting the last ones here over the next few weeks and making those connections, doing surveys to make sure all of those diffusers, right? We got to put the river bottom back exactly where it was when we started, and those diffusers stick up, and that's how we get our underwater mixing. So that's what's going on now. You can see the picture in the lower right was one that was taken a few weeks ago. And so that's a small little skid steer just to give you some scale perspective on those pipes. It's a big pipe. And then one of the things that really, so this project, moving our spot in the river really helped us with our NPDES permitting. And so we were able to work with DEQ to get an agreement that this would be brought online in 2026. The new outfall will be placed online. So we didn't get any kind of interim limits. So we were operating in our existing outfall and then our new outfall. And our new outfall provides us significantly better mixing, which when you look at siting an outfall, it's called a reasonable potential analysis. And so you look at like what you're discharging and how it might impact aquatic life. And so this spot in the river is significantly improved from our old spot, not only from a mixing perspective, but also moving it further away from the Clackamas River. It's out of the cold water refugia there for the Clackamas River. And so overall, this was a really beneficial project for the river. And the way we were able to permit it with the EQ was really beneficial as well, because it allowed us to go through the permit with both outfalls, both in the short term while we were building our new outfall and in the long term once our new outfall is in place. So I think, again, it's leveraging those relationships we have with our permit agency helped us navigate that, so we don't have to go back through and open up the permitting comment period again, which quite frankly we learned earlier that can be a challenge because you never know what positions or what thinks people or who's looking at it at that time. So cost, of course, this is the business community. I wanted to kind of touch through on our progressive design build approach. It wasn't a cheap project. It was a $58.4 million original construction contract. There was some amount of owner's allowance. Like I said, these risk buckets of money, we had about $1 million in buckets for us to own some of the risk around in-water work, window extensions, and things of that nature that the contractor really couldn't control. And so we had some money in there for that. Our current contract value, even with getting stuck and managing that, is still $58.4 million. And so, even if we were, thank you. If we use all of our owner allowance, that would put our kind of contract change at less than 2%, 1.6% is what we were carrying. And so if you've ever delivered public works projects, 1.6% change is pretty amazing. I would strive for that every project and be really happy. We don't see that very often, and so I'm pretty proud of kind of the level of conversations that went into risk and the planning and everything. It really helped us execute a good project. So major takeaways, just if you're going to go home with anything from this kind of story I told, is relationships are critical to all projects, whether it's with permit agencies, local business community, parks boards, and just relationships in general on the public are what's really going to make a difference in project delivery. Always be willing to adjust expectations, right? There's always going to be hurdles and things to come through, and so just you try to respond to them as they come through and keep a positive attitude. And then, as I mentioned, celebrate the successes, celebrate the process, and kind of enjoy yourself, because it's I've looked back, as I said, this is 7 years of my career. That's almost a third of my career I've been working on this project. It's been an amazing, wild ride, and I'm really proud to have led this project for Wes. Too many to acknowledge, but I just wanted to throw this slide up to acknowledge, some of the partner agencies, ODOT, the City of Oregon City, the Wes Board of Directors, I can't name them all, but that's just a short list of the folks that we acknowledge that had a say or a part in our project. And just from a Wes internal organization standpoint, I'll just say, right, this touches everything from our regulatory to finance, construction, operations, surface water. It touched everybody in our organization, quite frankly, in one way or shape. So those relationships, again, are what's critical. And then Greg was going to give this slide, but he's sick, so I have a few words on this slide. And so it sounds like a pretty expensive project, and it was. But, as I mentioned early on, these planning documents, we also have a financial plan. And so this was paid for we didn't have to raise rates just for this project, right? We raise rates regularly because things are more expensive to operate and run. But from our long-term financial plan, we had this project identified. We had the money for it. And so we're on schedule to complete it this year and operational in 2026. And really because of the kind of strategic, innovative, engaging efforts of our organization to plan not only from a financial, but from a capital and a facility planning for what we need to build, we were honored to receive this summer the Outstanding Member Agency Award from the Oregon Association of Clean Water Agencies this summer, which is really, a pretty prestigious award for us. It's it was a highlight for sure. And it wasn't just this project, it was overall our organization, from public outreach to, all of the things that went into it made it a really special experience for me, and I was proud to lead. Thank you.
Well, thank you very much, Jeff. We do have a number of questions from our audience, and if there's any more, please bring them forward. First, are there any drawbacks to the progressive build design on a project like this?
So I don't know about a drawback, but I think if I were to make changes to our documents, just some of the change management and identifying, you get a price at 60% design, and so there's some amount of contingencies in there for advancing the design forward, right? And so I would be much more clear in our documents on what's the baseline for change, right? And so that came up a lot in our conversations with the contractor on what was the basis of bid, or what was the basis of price, and should that have been included in the design contingency? So I think having real conversations around those would be something I might change a little bit in our documents moving forward as a drawback. And then the other part is, Michaels is a great tunneling contractor, but once the tunnel part was over, we got some different folks in to come manage the subconsultants, subcontractors they had doing some of the open cut work, and the shift in personnel was, I'll call it, painful for me personally. I had a really good relationship with the PM they had working, and not as great a relationship with the PM we have now. So those two things I think would be a hurdle. Those could happen on any project, quite frankly, not just progressive design build. And I don't want to, so I wouldn't use it for every project, right? There are certain projects, this one particularly had a lot of risk. That was really what pushed us to use it. I wouldn't use it for a greenfield project, probably maybe not the best, unless you're really up against schedule or hurdles or something like that that's driving it. This one was, we wanted to understand what somebody felt comfortable doing rather than us telling them what we would allow them to do. And so I think from that perspective, it was really beneficial for this project specifically.
Great. What do you expect the average daily flow will be through the pipe?
So our dry weather flow is around 14 million gallons a day. So in the summer months, when the groundwater is down, and what we always fight against in collection systems is leaky joints, or homeowners connecting sump pumps to our systems, or tree roots or failing pipes. And so we go out and CCTV, so we try to televise a certain percentage of our collection system every year so we can find those things and fix them. So that's our dry weather flow, is about 14. And in the wet weather, we're almost double that, but we can peak in a real big rain event. We go all the way up from, maybe if we're averaging 14, we can do 5 times that in a really heavy rain event. So we can get up to around 70 currently. And as we continue to build more pipeline, right, you continue to have places for those things to come in. And it's called inflow and infiltration. And Oregon City's got a great program. It's something that we support when we looked at our long-term capital planning. Do you build bigger treatment facilities, or do you make investments in maintaining and trying to bring our collection system, tighten it up? And so what Wes found in our facility planning and sewer master planning effort was, it was better for us regionally to make investments in our member communities, help them address I&I in very leaky basins, than build much bigger facilities to treat all of the flow that would come to us if we didn't address those deficiencies. And I'll give credit to Oregon City. They've had a really great I&I program. If you've not been to their webpage, it's worthwhile going and checking. And Wes is contributing, a portion of those project costs because it's what's best for the regional ratepayers.
Okay. How did you anticipate the water needs in 2080?
So whenever we're looking at long-term master planning, we use zoning. And so when we look at kind of what's in the urban growth boundary, or what could flow to our facility just from a geographical land lay, and then we look at those zonings and we apply. There's models that are developed or created for ours that apply to growth. And so there's 2 things: the zoning for what might be built there, and each of different zonings have an anticipated or an assumed flow that would come from that. And then the other piece of that is the rate of growth. And so we use forecasts that's developed by it's not Portland. Portland State University does a rate forecast. There's different groups, and so we use those to project out like how fast things will grow. So it's the zoning and the and the forecasting. That's what we look at to identify those.
All right. And what is the projected population growth over 10 years, and where will that come? You kind of touched on it, but
Sure. From a number standpoint, I don't know that answer, unfortunately. From a where it's going to occur, Happy Valley is the growth area that we see things going. We've got another project we're working on. It's a Rock Creek extension that's going to take a sewer we have up in Happy Valley and extend it all the way up from Troge Road all the way up to the service area there, where Happy Valley. But Happy Valley is really where we see in our service area specifically. I can't speak to the state, but our service area specifically is where a majority of the growth is we are anticipating.
great. And we've come to the end of our questions. Are there any other burning questions?
Not a question, but I just had a little announcement if I could when you wrap up.
Okay. Sounds good. All right.
Well, thank you very much. The diffuser pipes coming off the pipe, they're 18-inch diameter, and so the tide flex, if you were standing next to the tide flex valve, it comes, up to my chest from a height, and they're I would say vulcanized rubber, so to speak. They're like a car tire, and so what it is it keeps the river from coming back through our pipe in low flows, but it also helps us create kind of I'll call it an underwater sprinkler or an underwater spray, right? If you want to help mixing, you spread it out as much as possible, which is why we're discharging it over 18 ports underwater instead of just one big pipe coming out, right? The goal of a diffuser is really to help that mixing, to limit the amount of impact you have. They call it a plume. I hate to use that word, but it's your discharge plume. It's like how far will your water go before it kind of homogenizes with the river? And so the more you can spread it out, the broader you can get it, and the deeper you can go, the shorter that distance is. So, and I came and presented on this project before, and we're kind of bookending the project here. So thank you for listening to my story. It's been an awesome project, and I really appreciate all the support of the business community for this project and for us as an organization.
Jeff, thank you very much. Don't go away. I have some kudos for you, first of all. This presentation was kind of like the cap on the top of this, as far as I'm concerned. For those of you that don't know, I'm William Gifford, and I also serve on the West Advisory Board. And I've watched this project closely from the very beginning, as you know. And this presentation is a little different, I think, than some of the presentations that this group gets. Because, for one thing, it's very personal to you. And I could hear through the thread of your presentation how you have grown through this. And I really salute you for acknowledging that. And whether or not someone is interested in water recovery management, because a lot of people just say, that's underground, I don't care, I don't see it, it's not important to me, just get it done. The lesson to be learned, I think, today is how to manage an extraordinarily large project with the grace and finesse that you and your team have accomplished, and to be able to have that within a ridiculously small budget range, I think is a true accomplishment and a giant feather in your cap. So I salute you, sir.
Appreciate that. Thanks, William.